Welcome back. We are going to finish the 17a notes on this video here. And I know what you're thinking. Look at what a magician he is. He turned that 2 into a 3 for part 3. Yes, I know. I'm amazed too. So, we left off by we finally got the graphing calculator to show the graph that we wanted. Okay, and it asked us to sketch a graph of the function. So we're going to just give a little sketch of this on here. So let's do that. Okay, so let's do this over here so we have room to still see our calculator. All right. So we got this here. We know that it hits about here-ish. So let's just, again, we're just kind of sketching it. Comes up here. And it looks something like that. So there is our sketch. And then we're going to actually be able to find these points here. And we'll be able to better label our sketch here. All right, so we want to find the axes intercept. So this one right here, as we can see by this here, is going to be -1. Okay, so we've got one axes intercept here at -1. So let's see, axes intercept is x is at -1, and it's also, there's another one over here, and again these are all these tick marks here are by the x scale is 1, so we'll just count 1 on each one of those. So 1, 2, 3, 4, and 5. So this one here is at 5, so we have x-intercepts at -1 and 5. The y-intercepts are going to be this point right here. Okay, so by looking at that, we can't quite exactly tell where that's at. So let's have our calculator do the work. Okay, we could also plug in 0 for all of these here. And actually, that's really probably easier, isn't it? Because look, we don't need to have the calculator do our work for us, because if we plug in 0, if I plug in 0 for this one, this x here, this x here, and this x here, these all turn into zeros. And there is our y-intercept. Okay, so let's use that. Get rid of that so we can still read it. So our y-intercept is going to be at 15. It's going to be this number right there. All right, next thing, find the local minimums and maximums. This is where our graphing calculator is really going to help us out. Okay, so local minimum is right here. And that, again, we can tell is going to be at 0. So we have a, where'd it go? There we go. Local minimum is at when y equals 0. Okay. Okay, so we really want to write this as a point instead of just 0. So our local minimum we're going to have as -1, 0 is a local minimum. And then we also have this local maximum up here. So let's figure that out. Local maximum. And that one we can't just look at the graph and figure out what it is. We're going to have to use our handy dandy graphing calculator. And here is how you do it. It's really handy how we can do this. So what we're going to do is we're going to calculate what that maximum is. So what we're going to do is push second and then calculate. And then we want to calculate a maximum in this case. So here is our maximum. So we're going to push enter. And then we're going to get this little blinking cursor here. What we want to do is we want to get it close to the top, but not quite at the top on the left side, because it says left bound. So it basically means get this thing up close to the maximum on the left side of the maximum and push enter. And then it says right bound. So now we got to get that over onto the right side of the maximum and push enter. And then it's going to ask you, do you want the calculator to make a guess? And it's not even going to guess it, it's going to calculate it out. So we will say yes, we want you to guess. Push enter. It'll think for a second, and there's our x right there, our cursor right there at the very top at the minimum, which is x is 3 and our y is 96. So then we just do that our local max is at 396. Okay, so we've done these first three pieces here, and that just says add the axes intercepts, minimums, and maximums to your graph. There's our axes intercepts. This here is at 15, right? Local minimum is -1, 0. So let's do this. Let's make that into a point. We can make this into a point here also. 5, 0. And then this point up here we know is at 3, 96. Okay, and we've put everything onto our graph that we need. All right, one last piece. All right, Jerry, the owner of Bread Gloves R Us, estimates that the profit made from producing G sets of bread gloves is represented by the function blah, 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 blah. Jerry can only produce up to 300 sets of gloves per week. How many sets of bread gloves should Jerry make to maximize his profits? Okay, so what we need to do here is bust out our graphing calculator again. And what we're going to do is we're going to graph this thing. And we're going to see where the maximum is. So we're just going to go back and do basically a graph like this and find the maximum. So we'll enter this in, 0.002 x cubed. So we enter that all in. And again, we can push the graph button, and we're going to get a graph that is not going to make any sense to us. So again, what we have to do is simply just adjust the window. Okay, so the x minimum, we no longer need to leave at -10 because we can't make negative amount of bread gloves, although that might be a good idea with bread gloves, but we can't do that. So we have to, let's put in 0. And then the maximum actually tells us over here, I don't know why I had to move that, but he can only produce up to 300 sets of gloves. So what we're going to do for our max is put 300 in, because that's as far as we can go. X scale, let's make it go by, say, 50. And then the Y minimum, again, you can't have, negative amount on the Y. Let's change that into 0. And then the maximum, I mean, this is going to be his profit, right? So he could make a lot of profit here. So I don't know, let's do 1,000. Again, this is just a guess. We just have to try to figure it out. We'll go up by 100, and then let's graph it and see what we get. So here's our graph, shoots way up here, and then comes way down there. So we got to go way more than 1,000. All right, so window. Let's go back to, instead of 1,000, let's do, again, it looked like it was way up there. I'm just going to put in 100,000. Wow, this bread glove thing is quite lucrative, apparently. Let's make this every 10,000, just so we can at least get a few lines without it looking ridiculous. So there we go. It looks like it's about 2,000 or maybe a little bit less. So you could leave it like this, but I'm going to go back and at least make it a little bit smaller. So sorry, instead of 100,000, let's make this 20,000. Let's make it 25,000, and then graph that thing. There we go. Yeah, it doesn't even make it up to 2. So this right here is the point we're looking for. That's when he's going to maximize his profit. So let's calculate that maximum. Right? And again, it says, first thing it says is left bound, so you got to get it to the left of the maximum. Push enter. Right bound, get it to the right side of the maximum. Push enter. And then take a guess. Heck yeah. And there we go. X is 109.3, so let's round it off to these to the nearest whole number. So 109, and then we get, I'm not going to be able to remember that, so we get max at 109. And then the other number is 14,392. Let's just go with 14,392. 14,392 are our two numbers. Okay, so it says how many sets of bread gloves should Jerry make in order to maximize profit? That is going to be our x-axis, so he needs to make 109 bread gloves. And it didn't ask us, but that means that his profits when he makes 109 pair of bread gloves will be 14,392. So apparently we need to get into the bread glove business. Okay, that's it. So you should be able to say now that I can find local minimums and maximums of cubics, and I can use equations of cubic functions to solve real-world type problems. All right? If you have any questions, please ask. Thanks.